I'm Ralph Bright, Vice President of Marketing for Interpower Corporation. With me today is Bob Wersen, Founder and President of Interpower Corporation and Managing Director of Interpower Components Limited. Bob, thanks for joining me today.
And thanks for inviting me, Ralph.
Bob, what are some of the things that equipment designers ought to be considering when designing their product for export?
Well, there are four categories of things that the equipment designer ought to be looking at, and I'll present them in no particular order. The first are the power mains connection standards, the pins and socket configurations. The second are the voltages in use throughout the world today. The third are the frequencies, again, the power mains frequencies. And the last are the product regulatory agencies and their views on things which vary country by country around the world.
Let's go over these one by one if we can. Tell us about the different mains connection standards in current use.
Well, there are at least 20, in fact I think 21 at last count, connection standards used in the world today. These are different plugs and socket combinations. Some of them look very similar, but they are different, and it's important to recognize that product safety regulations in almost every country in the world require that products be shipped and have the correct power cord or cord set connected to them when they enter their countries. So we've got to get it right the first time.
Now, does this mean that the equipment producer has to offer a different version of their product for each country or country group?
No, the equipment remains the same. What changes is particularly with a detachable cord set, all you change is the cord set. And it's quite easy then to configure the product with the particular country's specifications in mind. Now, we put on the screen at this point a wall chart which shows the various plugs and sockets used throughout the world today. And you can see the URL up there where you can access this. This is designed as a very useful tool for you in specifying cords and cord sets.
Let's move on to the mains voltages. What does the designer need to know in regards to the power mains voltages used around the world?
Well, there are two mains voltages in common use in the world today, 115 volts and 230 volts. Of course, here in North America, we're using 115 volts nominally. Japan is an exception where they operate at 100 volts. And there are some other countries that operate anywhere from 110 to 127 volts. At the higher end of the scale, Europe operates nominally at 230 volts, and most of the countries in Europe are either at or are moving towards 230 volts. There are other countries in the world that operate at 220 volts, 240 volts, and Western Australia operates at 250 volts. So it's quite a range. Now, with auto-ranging and universal input power supplies, that doesn't present a problem for most electronic equipment, but for equipment that includes inductive components, and I'll pay particular attention here to fans, that can be a problem. And so it's important to make sure that the inductive component will operate at whatever voltage is required.
And what about the mains frequencies?
Well, that's similar. There are two mains frequencies that are in common use, 50 and 60 hertz. Again, in North America, we commonly use 60 hertz, and that's also the frequency used in the northern part of South America. Most of the rest of the world operates at 50 hertz. Japan is again an exception because it's both 60 hertz and 50 hertz in different parts of the country. Again, auto-ranging and universal input power supplies eliminate that as a problem for electronic equipment, but with inductive components, and again particularly fans, it's really important to take the frequency into consideration and probably specify 50 hertz components in those situations where the equipment will be sold in both North America and in international markets.
The final issue is the national test and standard agencies. Tell us about the implication of the standard compliance for equipment designers.
Well, standards compliance is extraordinarily complex, and it's a moving target, which makes it even more challenging. I suggest that most designers start with the International Electrotechnical Standard for the particular appliance they're making. Now, that's also known as the IEC, great place to start, and then make a list of all of the countries to which their equipment is going to be shipped, and make sure that the national standards don't deviate from the international standards. Most of Europe is pretty well aligned with the IEC standards with minimal national deviations today. Where you will find national deviations is in the developing world where the standards are changing quickly. And there are deviations there that you really need to take into account.
Sounds like a lot of work.
Well, it is a lot of work, Ralph, but keep in mind that the whole objective is to design a single product that can be sold globally. The company that can do that can amortize the cost of product development over a considerably larger production volume and end up with a significant competitive advantage. That makes it all worthwhile.
Thank you, Bob, for explaining the ins and outs of power system design.
Well, and thank you for inviting me, Ralph.
For Interpower, I'm Ralph Bray.